A z-score is a measure of how many standard deviations a piece of data is away from the mean. The following formulas can convert back and forth between z-scores and x values. Let's try to use these formulas to find z-scores for each of the following x values. And then we'll plot them on a normal curve. Say the incubation period for a type of bird's eggs is normally distributed with a mean time of 336 hours and a standard deviation of 3.5 hours. What would be the z-score of an egg that hatches in the following times? What about 336 hours? Notice that this happens to be the mean time for hatching of this type of egg. Since it's the mean, that would be plotted here. And what we'd also like to do is, in addition to the x scale, we also want to make a z scale. And we'll plug into the formula to find out what z value corresponds to 336. The formula says it'll be x minus the population mean divided by the standard deviation of the population. So this is going to be 336 being the time in question. Then we subtract the mean, which is also 336. And then we want to divide by the standard deviation, which is 3.5 hours. In this case, the calculation comes out to 0, and 0 is the z-score that goes under the peak of the normal curve. So this is the answer for that one. Now let's find out what the z-score would be for an egg that hatches in 338 hours, a little bit more than the mean. All right, we're going to have 338 minus 336 here. And we'll divide by 3.5. I get 0.29 approximately. All right, so where does this occur? Well, our first standard deviation above the mean will happen at the inflection point of the curve. That's where the curve goes straight for just an instant. So we expect to see a z of positive 1 there and a z of negative 1 there. So whereas our 336 fell right in the middle, that was A, I believe our B will be just slightly off to the right here, at about there. That's going to be our 338 as an x value. And it has a 0.29 z value. Now let's try 345 hours. We expect to get a much larger z-score for this. .57. All right, so we're going to have to find the second standard deviation here. And we're going to have to go even farther than that. 2.5 might be around here. And this was 345 hours and a 2.57 z-score. That was C. Okay, lastly, 324 hours, way below average. So this egg hatched early. It's got a score of negative 3.43. Okay, if we go 2 standard deviations below, we'll be here. 3 would be about there. We're going to go even farther. We're basically off the drawing here. That's 324 hours and a negative 3.43 z-score. All right, so one other term that we should know when it comes to z-scores is the definition of unusual and highly unusual. So unusual scores would be anything that is beyond 2 or negative 2. These are considered usual. Okay, anything between negative 2 and 2 is usual. If we go beyond 2, then we're talking about something which is unusual. And if we go beyond 3 or beyond negative 3, then it would be highly unusual.